Okay, everyone, I was going to take a minute to kind of explain the 1033 Lionel transformer. So we have four posts here, U, A, B, C. These are right at the top. And this is kind of a wiring diagram of how everything is wired inside. We got a lot going on here, a lot of wires, but it's easier to break it down into the different combinations that you're going to use. So um, let's start out. So you plug it into the wall, right? And you get 110 volts in a coil. Okay, that coil is going to be always live and it's going to generate a magnetic field, electromagnetic field. And so we have three windings inside here. This one's going to output 5 volts, 5 volts, 11 volts. So we have 1, 2, 3, 4, 5, 6 wires, output wires coming out of the transformer, and we have 2 input wires. And so these are, variable based on how many windings. So 11 is going to have more windings than 5. I don't know the actual number. But you can see U has quite a bit going on right here. A is pretty simple. B has a breaker right here. And C, between B and C, we have this thing here. This is the wiper arm. So this is going to swing back and forth, and this is going to be kind of 0 volts. And then when as it that's going to be 11 volts. So let's kind of break it down. You're not going to use all these wires at the same time. You could, but generally you're going to pick which one you want for what you're doing. So I'm going to put this master diagram kind of over here so we can refer back to it. Um, but this is the two main ones you're going to use to run trains, U to A and U to B. So the way this works is this right here is the orange handle. And when you put it in, was it reverse? It's going to click this into a dead spot and it's going to kill all power to the track. So real simple, it just kills, when you move this over here, it kills the track. When you move it over here, that's the whistle button. We're going to direct flow from this way to this new one, which is literally this 5. This left hand 5 is only for whistle. It is your whistle coil, whistle windings. And so we're going to send that white resistor is this guy right here, and then a diode. The old diodes are going to be, it's a selenium disc, which is real old vintage stuff. Or you can upgrade it to a standard diode. So this is going to give you a 5 volt that's resistored. So it's a slowed down 5 volt with a DC shift to it. It is the wackiest AC you've ever seen. So it's going to be a wimpy AC that's been shifted up to give you a DC-ish AC. And that's what the train is going to see in order for it to activate the whistle. So it's going to do its thing. It's going to go around here and it's going to come around here. And so if you're at 0 volts, you're going to get 5 volts here. So even if your train is stopped, you're still going to be able to power the whistle because you got 5 volts going through here, I believe. I'm pretty sure. But let's say you're running the train. Let's say you're running it at half speed. Let's say you're running it halfway on the throttle. That's going to give you 5 volts here. So now it's going to go 5 volts and then 5 volts. But this is not going to be 5 volts. It's so that's why you kind of get a little jump. Your train is going to give a little bit of a jump when you hit that whistle button because you're getting that bonus 5 volts. So you got 0 volts. You're going to get a little bit of not enough to power the train, but I think it's enough to power the whistle. But so when you're going full speed at 11 volts, and on A, you get this bonus loop. So on B, okay, so that's the whistle. That's the whistle. That's the clockwise, counterclockwise for the orange knob, and then this is going to be the black knob. We got 0 volts, 11 volts here. So you you get a breaker here. If you short anything out, you do have a breaker here. And so if you go from U to A, the lowest you're gonna go is 5 volts because you're coming down here, you're hitting this 5, you're going through the breaker, you're coming down, and so you're gonna get 5 is the lowest, and then 5 plus 11 is gonna be your 16. So you're gonna get 16 volts at the highest. So if you want a little faster, if you want a little more power, you're gonna do a U to A. Now, if you're trying to go a little slower and you don't want that 5 volt bonus, you're going to go the same thing, but you're just missing out on this bonus 5. So you're going to come around here. You're going to do your variable. You're going to come around here. So 0, breaker, B. So here we go, and then we're gonna add to this, get some of this, and then 11, and now we're at full blast. So those are your two variable options: U to A, U to B. Now, the other ones are just kind of like, I don't know, bonus things that, since they have all this wiring in here, these are the two other ones. Now, A to B, if you look over here, A coming around B, so you got 5, 5, 5. A to B, we use this 5 in the B section, but you can also go from A to B. So that's what this is. A to B is going to give you a standard 5 volts. Now, the way this is wired, the connection for A is right here. It's not right here. So you are bypassing the breaker. You do not have a breaker here. When you go from A to B, no breaker. Now, B to C, we're going to come around and grab some of this stuff. So 11 volts, and you do get a breaker here. So B to C, no variable, just 11 volts. So A to B, 5, B to C, 11, and then A to C, we're going to get the 5 plus the 11, and we're going to hit 16 right here. And we do get a breaker if we go that way. So fairly simple. But yeah, you see all these wires here, but yeah, you're just connecting them together like that. Now, there is one more bonus. Now, U to C. No one ever talks about U to C. Why? Because it does not work. That's the. I'll show you. So this is the U. This is the whole circuit for the whistle control. But when you're coming around here, U to C. C is kind of the back end of this this setup. So it's gonna be, if you connect it here, right? It's connecting to C. And then if you connect to here, you're picking up some of the windings, but you're kind of going backwards. So will this work? Throttle is backwards, so um, you're not gonna get any real power to it. I think, let's see, if you have this at 0, you're gonna get 11 volts, right? So C, 11 volts, kind of backwards, and then we're gonna come around here. So yes, you do get, if you're right here. So the handle is going to be backwards on C, and it looks like you still would get whistle. I don't know. It's not really in the charts because it's not really something you can do. But that would be U to C. That's why U to C doesn't really work. The handle's backwards, and your voltage is going to be weird. There are better ways to do it through here. So that